imagine that we have images of dumbbells, which are all grouped together on this area of our graph here. And now imagine that we have a model that we're using for classification purposes to classify images as either dumbbells or kettlebells. So for classification tasks, what the model is doing is actually drawing a boundary between these classes. It's trying to find the boundary that best separates these classes in the most accurate way. So this dotted line here is the best that the network can do when it has to cut through the origin. And we can see that when it creates this boundary, that some of these areas that are outlined in this region here, some of these kettlebells in this case are being misclassified as dumbbells. So if we just look at what the network might be able to do, if we can actually vary our y-intercept, we can see that it's able to create this boundary much more successfully. The reason why that is that if we look at this boundary now, it's not required to cut through the origin. So the network was able to decide the y-intercept, or both the slope and the y-intercept of this best fit line, which appropriately separates the data. Whereas before, it only had the ability to vary the slope, meaning the weights of the network, and it had to cut through the origin, and we saw that that was not the best fit boundary.